Okay, let's move on to number 8. Oh, there's a whole lot going on here. Let's see here. All right. If no denominator equals 0, which expression is equivalent to 25 minus 4x squared times 6x squared plus 9x minus 15 times 6x squared minus 2x minus 4 over 2x squared minus x minus 10. Whole lot to do here. Now, one thing that you have to realize is that you must factor the numerator and denominator in both of these fractions, because the numerator and denominator in both of these fractions, they all factor out. So let's just start with the first fraction. Now, 25 minus 4x squared, if you're keen, you should recognize that this could be a difference of squares. We just need to do a little bit of manipulation on it to figure that out. So if I multiply the numerator and denominator by -1 here, now the 25 minus 4x squared, wouldn't that become a minus 25 and a positive 4x squared, or simply 4x squared minus 25? So you should easily recognize that as a difference of squares. Multiplying the denominator by a -1 is going to give me a negative 6x squared minus 9x plus 15. Then I'm just bringing down the second fraction for now. I'm going to factor that later. Now, the 4x squared minus 25, you should be able to factor that as 2x plus 5, 2x minus 5, factoring differences of squares. With the denominator, you should see that I can factor a -3 out of each of the terms, and when I do that, I get a 2x squared plus 3x minus 5. Again, I'm just bringing down the second fraction right now because I want to finish factoring the first. Now, 2x squared plus 3x minus 5 also factors. And that factors to be 2x plus 5 times x minus 1. 2x times x is 2x squared. 2x times 1 is a negative 2x plus 5x. This gives me the 3x. Positive 5, negative 1 gives me the negative 5. So I have my first fraction fully factored here. Now, let's look at our second fraction. Now, I start with 6x squared minus 2x minus 4. Well, I see I can pull a 2 out of each one of these terms, and if I pull a 2 out, I'm left with 3x squared minus x minus 2. Now, this also factors, and it factors to be 2 times 3x plus 2 x minus 1. You need to have a good command of factoring in order to answer this question. So we have 3 out of 4 factored. Now let's go to the 2x squared minus x minus 10. This factors as well, and it factors to be 2x minus 5 times x plus 2. So now we have the numerator and denominator and both fractions fully factored. Now that it's fully factored, I can just start canceling all over the place. Well, let's see. I can cancel the 2x plus 5 here and here. I can cancel the 2x minus 5 here and here. I can cancel the x minus 1 here and here. And when all the smoke clears, what's left in my numerator is the 2 times 3x plus 2. In the denominator, what's left is that negative 3 and the x plus 2. So here's my numerator, here's my denominator. Again, if the negative is in the denominator or the numerator, it's still a negative fraction. So I can just move that negative up here, and it matches choice C here. Again, if this one kind of went a little bit too fast for you, you just basically need to practice factoring polynomials, and that's what's going to help you get this question. Let's move on to question 9. Assuming the denominators do not equal 0, which expression is equivalent to 12 over x plus 1 over x minus 4? Well, since whenever we're adding or subtracting fractions, we have to make sure that the denominators match. And in order for the denominators to match, we find the lowest common denominator. In this case, is going to be this denominator times this denominator, which is x plus 1 times x minus 4. So in order to make both fractions have the same denominator, the first fraction, 12 divided by x plus 1, I'm going to multiply by x minus 4 over x minus 4. And then the second fraction, 1 over x minus 4, I'm going to multiply by x plus 1 over x plus 1. Now, you'll notice that they'll both have the same denominator after I finish. Now, if I distribute the 12 here, that's going to give me a 12x minus 48. Here, 1 times anything is just whatever x plus 1. So now I have 12x minus 48 over x plus 1 times x minus 4 plus x plus 1 over the same denominator, x plus 1, x minus 4. Since they have the same denominator, all I need to do is add the numerators and simplify. 12x plus x is 13x, negative 48 plus 1 minus 47 over x plus 1 times x plus 4, which matches answer choice A. Okay? Moving right along here, let's go on to question 10. Which expression is equivalent to the square root of 36x to the 9th, y to the 25th, where y is greater than 0, where x is greater than 0 and y is greater than 0? Again, I tell my students to take the radical, break it into separate radicals, and then simplify later on. Now, with this radical 36x to the 9th, y to the 25th, I could break this as the square root of 36 times the square root of x to the 9th times the square root of y to the 25th. Since it's asking for the square root of all of them, right? Taking them separately, square root of 36 is just 6, because 6 times 6 is 36. Now, the square root of x to the 9th, this is in radical form. What I would do is just simply convert it to exponential form. The square root of x to the 9th is simply x to the 9 halves in exponential form. Same here. Square root of y to the 25th converted to exponential form is y to the 25 over 2. So what I have is 6 times x to the 9 halves, y to the 25 halves, which answer matches answer choice B. Okay? Okay, this is rather simple. Let's keep going. All right, question 11. What non-zero value of x is a solution to the following equation? X plus 2 over x plus x minus 6 over x equals 2x plus 9 over 5x. Okay, so we're adding fractions here. And we have a denominator of x, 3x, and 5x. We need to find the least common denominator in common between each of these so that we can add and then simplify later. Now, the least common denominator between them is 15x, because each one of these can go into 15x. So now to make the denominators match at 15x, I'm going to take that first fraction, x plus 2 over x, multiplied by 15 over 15. That's going to give me 15x there. I'm going to take the second fraction, x minus 6 over 3x, multiplied by 5 over 5. That's going to give me 15x in the denominator there. And then I'm going to take the 2x plus 9 over 5x multiplied by 3 over 3. That's going to give me 15x there. So now that the denominators are matching, I just need to take care of these numerators. So here, if I distribute 15 times x plus 2, that's going to give me 15x plus 30. Distributing the 5 to the x minus 6, that's going to give me a 5x minus 30. Distributing the 3 to the 2x plus 9 gives me 6x plus 27. Now, we notice the denominators. Since the denominators match, now all I'm going to do is concern myself with the numerators. So 15x plus 30 plus 5x minus 30 equals 6x plus 27. I'm going to simplify this part. 15x plus 5x is 20x. 30 minus 30 cancels each other out. So 20x equals 6x plus 27. Now I'm going to subtract 6x on both sides. I get 14x equals 27. I divide by 14 both sides. X equals 27 over 14, which matches answer choice A. Okay? Now we're moving right along here. Oh, we're cooking with Crisco. Okay. How many values of x will satisfy the equation -2 times the absolute value 3x minus 5 equals 0? There's two ways we can do this. We can graph it or solve it. First, you know what? Let's go ahead and graph it and see what we get here. Let me pull up my calculator here. Let me clear this. Graph this. So -2, hit my math key, num for absolute value, 3x minus 5. I'm going to place that there, equals 0. So I'm going to go in y2, I'm going to hit 0. And let's graph this and let's see what it looks like. Okay, so it looks like we're just getting one value here. One value. So 1 looks like it could be our answer, but that's by graphing. Now, what if we solve it by hand? Let's see what happens here. So if I take the equation negative 2 times the absolute value 3x minus 5 equals 0, I divide by negative 2 both sides, I'm going to have the absolute value of 3x minus 5 equals 0. And remember, with absolute value, you're going to split it into 2 separate equations and solve for each. So that basically means 3x minus 5 equals positive or negative 0. Well, we know that 0 is not positive or negative. I'm just putting that there for effect. So 3x minus 5 equals positive 0, which we know it's just 0. If I add 5 to both sides, I get 3x equals 5. I divide by 3 on both sides, x equals 5/3. Now here, 3x minus 5 equals negative 0, which is, again, just 0. I just put the positive and negatives for effect. Adding 5 to both sides, we get 3x equals 5. Dividing by 3, both x equals 5/3. So we get 2 answers, but both of the answers are the same, 5/3. There are 2 answers, but they each have the same value, so there's only one value of x. So to answer the question, one value of x, even though we got 2 answers by graph, and here it's only one value of x. Okay, let's move on to question 13. Which graph best represents the solutions for y is less than the absolute value of x plus 4 minus 1? Well, looking at this particular expression, we know the vertex is going to be 4. If it's positive, that means the vertex is 4 to the left and 1 down. Now, looking at the 4 pictures that we have, only 2 of them have the vertex at 4 to the left and 1 down. A and B both have the vertex as 4 left and 1 down. But let's look at here, y is less than. So we have to look at which one is shaded less than. This one, A, is shaded greater than, B is shaded less than. So B would be the correct answer. Okay. Let's move on to number 14. What is the solution of the square root of 7 minus 2x plus 5 equals 8? Well, we'll write it out here. If we subtract 5 on both sides, that's going to give us the square root of 7 minus 2x equals 3. Now, we want to get rid of this radical sign on the left, so we're going to square both sides of the equation, because the square root of anything squared gets rid of the radical. So that's simply 7 minus 2x, and then 3 squared is 9. If I subtract 7 on both sides, I'm going to get negative 2x equals positive 2. Then if I divide by negative 2 both sides to get the x by itself, x equals negative 1, which is answer choice D. That one was pretty straightforward, not too many problems there. Okay. Question 15, which is the apparent solution set of the system of equations graphed on the following grid? Well, the solution set is basically wherever the 2 equations intersect, and they seem to intersect there and there. Here, looks like that's negative 4, positive 3. Here, that looks like negative 1, 0. So the answer choice is C of negative 4, positive 3, and negative 1, 0 would be appropriate. Again, that's another easy one. That's a freebie. Let's go on to 16. Okay, this graph best represents the solution to which equality? Graph, well, I wrote graph or solve because you can find the answer either by graphing or by solving. And I went ahead and tested them all out in advance and found that answer D is the one that actually satisfies the equation. First, let's look at it by solving it by hand. Okay, so we have the absolute value of 2x plus 7 is less than 15. We split that into 2 separate expressions. It's going to be 2x plus 7 is less than 15, or 2x plus 7 is greater than negative 15. Remember, we flip it when we're solving absolute value expressions. First one here, if I subtract 7 on both sides, I get 2x is less than 8. If I divide by 2 both sides, x is less than 4. Fairly simple. Now here, if I subtract 7 both sides, I'm going to get 2x greater than negative 22. I divide by 2 both sides, x greater than negative 11. So that's what we get by solving. Now let's punch this into our calculator and let's see what we get. Let's turn it back on. And let's clear out what I have in here previously. So what I'm going to do in y1, I go to math, num, absolute value. I'm going to place in 2x plus 7. And in y2, I'm going to place in 15. Now, normally our viewing window is set from negative 10 to positive 10, so I'm going to adjust my viewing window so I can see everything here. So I'm going to go to my viewing window, and I'm just basically going to double these numbers, negative 20, positive 22. You can set your viewing window to whatever you wish. I just find this simpler to do it this way so I can see everything. So I readjusted my viewing window. Now I'm going to hit graph. So that's the absolute value of 2x plus 7. And then that is y equals 15. So now these points of intersection right here, which I've already done it here for you, but I'm just going to do it on calculator here. So now solving, we got x is less than 4 and x is greater than negative 11. So what we have here on this graph, x is less than 4, x is greater than negative 11. So these points should be 4 and 11 where they intersect. Let's find out if that's so. If I go second trace intersect, and let's go right here. That's my left bound. It's my right bound. Guess x equals negative 11. And then if I do it again, this should be 4. Second trace intersect. And I come back over this way. Okay. It's my left bound. Right bound, guess. And x equals 4. So basically everything in between 4 and negative 11, that solves it. It matches what we have here. Make sense? Okay.